A real estate office handles a 40-unit apartment complex. When the rent is $500 per month, all units are occupied. For each $30 increase in rent, an average of one unit becomes vacant. Each occupied unit requires an average of $40 per month for service and repairs. What rent should be charged to obtain a maximum profit? In this one, let's let X be the number of rent increases. For this particular problem, $30. Profit, recall that is revenue minus cost. Revenue is the money coming in, so that is the rent charged times number of apartments that are being rented. Cost is the money going out. That's $40 for each apartment that is being rented. For rent, we have a starting amount of $500 per month, and then depending on how many increases there are, we're going to add $30 increases each time the rent goes up. Now recall, every time the rent goes up $30, the number of apartments reduces by one. So the number of apartments that are being rented will be 40 minus however many increases of rent there are. So we have the rent in dollars times the number of apartments that will be rented based on the number of increases. So this is the money coming in. The money going out will be $40 times the number of apartments rented. And again, that's based on the number of rent increases. Okay, so let's do some subtraction. Subtracting, now remember this in here, what I'm going to do is I'm going to change this to a plus sign, move the negative inside, and that way when we distribute, it's a little easier to keep up with the negative. So FOIL 500 times 40, that's 20,000. Outer, that's negative 500x. Inside is 1200x. Last, negative 30x squared. So what you see underlined in blue is a result of FOIL from the first two. Minus 1600 plus 40x. So distributing negative 40 gives you what's underlined in pink. Combining like terms, we have a negative 30x squared minus 500 plus 1200 plus 40, and there's three terms that are like with the x's. Grand total 740x. There are some constants, 20,000 and minus 1,600. That's 18,400. Since we're trying to maximize profit, once we've got our like terms combined, we take the derivative, that's negative 60x plus 740. This number is a constant. It goes to 0 when you take the derivative. Solving for x, when we put this equal to 0, let's add 60x to both sides. 60x equals 740. Divide by 60. And that is approximately 12 increases in rent. Now the rent that will be charged if there are 12 $30 increases, that will be a rent of $860 per month. Now, if you think about this, you would almost bet or think that if you rented them all out, you would maximize your profit. It turns out that's not the case. The maximum profit occurs when $860 is charged each month. Now, because that's 12 increases, if you take 40 minus 12, what is that? That's 28. That means 28 apartments are being rented at that dollar amount. Let's do a follow-up example. Basically just changing the numbers up a little bit. Same procedure. A real estate office handles a 40-unit apartment complex. When the rent is $570 per month, and this is one of the numbers I changed, all units are occupied. For each $20 increase in rent, an average of one unit becomes vacant. Each occupied unit requires an average of $45 per month for service and repairs. What rent should be charged to obtain a maximum profit? Again, this is just a follow-up example with a few numbers regenerated, which is what you'll find in your WebAssign account. Profit is rent times number of apartments. That's the revenue, the money coming in, minus the money going out, which will be $45 per month for service and repairs, times the number of apartments that require it. FOIL, 570 times 40, 570 times negative x, 20x times 40, and 20x times negative x. I changed the minus to a plus and scooted the negative inside. That makes it easier to distribute a negative 45. Negative 45 times 40, negative 45 times negative x. Combining like terms, we have a negative 20x squared. Now for the x's, it's negative 570 plus 800 plus 45. That's a total of 275x. 22,800 minus 1,800, that's 21,000. This was our profit function based on the number of rent increases. To maximize that, P prime, that's negative 40x plus 275 plus 0. Setting that derivative equal to 0, we're going to solve for x when we have 275 divided by 40, so approximately 7 rent increases. And so our rent will be $570 plus 7 $20 increases for a grand total of $710 per month. Now, a new example, and on the next video we'll have some more examples of this type. When a wholesaler sold a product at $30 per unit, sales were 310 units per week. After a price increase of $5, the average number of units sold dropped to 285 per week. Assuming that the demand function is linear, what price per unit will yield a maximum total of revenue? Maximum total revenue. So we're going to set up this information given in ordered pairs: number of units and price. The first sentence told us that when the price was $30 per unit, 310 units were sold in that week. But when the price was upped by $5, increased to $35, the number of units sold dropped to 285. We are told that the demand function is linear, so what we're doing is we're going to eventually build a lowercase p price or demand function that we've seen in previous videos, but this is the first time we've had to build one. The change in price, calculated as a slope, will be price 2 minus price 1, that's 35 minus 30, which is 5, over number of units sold, so units 2 minus units 1, 285 minus 310. If you think back to your college algebra days, it's y2 minus y1 over x2 minus x1. It really is just the slope formula. We have 5 as the numerator, negative 25 as the denominator, which reduces to a negative 1/5. The way to interpret this is when the price went up $5, production went down 25 units. All right, so now we're going to go back, think of this as, back in the college algebra days, as point slope form. I'm going to choose this first ordered pair and the slope we just found, p minus 30 equals slope times x minus 310. In college algebra, the formula was really gnarly looking. It was y2 minus y1 equals m parentheses x minus, or excuse me, x2 minus x1. Point slope form. But we have these in applications now. So again, p minus 30 equals slope times x minus 310. Distributing negative 1/5 times x plus 1/5 times 310, that's 62. Add 30 to both sides and we have a price function or a demand function of negative 1/5 x plus 92. Now we can build revenue. Revenue is x times p. So x times the price function we just built, that will be a negative 1/5 x squared plus 92x. Taking the derivative, because we're supposed to maximize revenue, that derivative is negative 2/5 x plus 92, setting that equal to 0. 92 divided by 2/5. Be very careful calculating that. You can also calculate that as 92 times 5/2. Just do the reciprocal. So anyway, 92 times 5, that's 460 divided by 2. That tells us 230 units. Backtrack to our price function. The price, when 230 units are produced, 230 units maximizes revenue, and so the price that should be charged for 230 units would be $46 per unit. In the next video, we'll look at another example. Let me know if you have any questions. Reach out by phone or email. If you're on campus, swing by the office. I'll do my best to help you out.